section on our website. You're all welcome to ask questions in the questions and answers panel, and in the end of the event, Peter will answer them. If due to time limitations your questions are not answered today, we'll certainly contact you with a response by email. This webinar will last about 1 hour. Thank you all for participating today. Peter, the word is yours.
Thank you very much. Hello everyone. We'll talk today about semantic data integration, and we'll show you some of the features of the new GraphDB, but it's also an insight into our new training portfolio. So let me first spend a couple of minutes talking about this training portfolio. We have a few interesting courses coming up. The first of which is focused on a general introduction into semantic technologies. So in this course, we give you an idea of what the semantic technology landscape looks like, what are the important concepts that you need to understand. We teach you about the resource description framework and what are the advantages to using it. We also cover very extensively ontologies and how you can use them to inference new facts from data. And we also, of course, discuss Sparkle, which is the query language of the semantic web. And finally, the biggest advantage in my view of the semantic web, the availability of linked open data. As some of you may know, that RDF is the standard format for expressing data in the linked open data community. Apart from this course, we also have 3 courses on GraphDB, tuned for different audiences. The first one, of course, is for people who are new to graph databases, and here we basically teach you how you can use GraphDB, why you might want to use it, so what are the advantages, how you can use it to cut costs and increase the revenue of your business. And we also discuss a lot of domain-specific use cases. Of course, there are 2 courses for one for more advanced users and for developers, and another one for people who are responsible for administering GraphDB. In addition to those courses, we also have a course which is exclusively focused on discussing use cases, semantic solutions, and reference architectures that are, this course I think is very helpful for business people who are trying to figure out what is the benefit of using semantic technologies. And of course, in addition to that, in tune with the whole community, we also offer a couple of courses on open resources such as Gate, which is a great resource if you want to do text analytics and semantics. It's developed by the University of Sheffield, and of course also the Eclipse RDF4J, or previously known as Sesame. It's a great framework for using RDF in Java. So before we go into the particulars of today's demo, let me also thank those of you who have already contributed to our survey. We really appreciate your results, and we've also found a couple of interesting results already coming from your feedback. It seems that about half of you are already experienced with graph databases, while the others aren't. I hope today's demo is as useful for those of you who are already familiar with the technologies, as well as for those of you that are just starting. I encourage those of you who haven't already filled out this survey to do so at the end of the webinar, so we can use your feedback to develop better webinars in the future. With that said, let me now start talking about how exactly you might want to integrate data coming from different sources. To do that, today I've picked a simple example using 2 pages in Wikipedia. The first one lists the largest companies in the world based on their annual revenue. And we have here a list of about 50 companies. And the second list is a list of countries ranked by their nominal GDP. And we'll show you how exactly you can take those different data sets and you can link them together and maybe get some insights from the data. So if you have the data in such a format and you want to play around with it, the first thing you will do is copy some of the data. Here I pick only the top 50 countries. So you copy the data, you open your favorite text editor, and you simply paste it. You then save the data, and the next thing you want to do is you want to go to GraphDB. To do that, first, of course, you need to download GraphDB, and you do that by going to our website, ontotext.com. From there, you click on Products, GraphDB, and if you scroll down here, you can also see that you can explore all of our editions, and you can use this nice table to compare the different features. We have 5 editions of GraphDB at the moment. Those are the standard, the enterprise edition, the free edition, as well as 2 cloud editions. One is GraphDB as a service, or S4, and the other one is GraphDB Cloud. The main difference between the 2 is that one is self-managed, the GraphDB Cloud, while the other one, S4, is managed by our team in-house. And it also adds a couple of other nice features. We'll be developing a webinar on this particular edition in the near future, so if you're interested in that, I encourage you to join us then. If you decide to start using GraphDB now, you can always download the free edition, which is the same as the standard GraphDB edition, apart from the fact that you can only run 2 parallel queries at any given time. So once you've downloaded GraphDB and you've run it, you can access the GraphDB workbench from your browser at this address here, localhost 7200. Now I'm showing you what the GraphDB 8 looks like. This edition will be made available over the coming couple of weeks, so stay tuned and check our website regularly to make sure you download it once it becomes available. So the main new things that in GraphDB 8 that we'll discuss today, one is the user interface, which has been made much more intuitive and easier to use, and also the other new feature that we'll focus on today is the ability to handle tabular data as the data in the wiki pages that I've shown. So once you've copied your data and you've edited it and you pasted it into your favorite text browser, what you do is you go to the GraphDB workbench. From there, you can go to import, tabular, or Ontotext, and here you can create a new project. You pick the file where you saved your data. So here the file was wikilist GDP as we copied the data for the countries. We click on next, and after a couple of seconds, it's loaded. Here you have the ability to choose how you want to parse your data. You might have noticed that the data seems to be separated by tabs. So we want to click here on the TSV option, and immediately you see it starts looking more like what it did in Wikipedia. The first thing you notice is the first line is already assumed to be the column headers. You can also modify this here. And we also see that the first two lines are things we wouldn't really need, as we're interested in the GDPs of the individual countries. We would remove the information about the world that you see here. So to do this, you tick this box and you specify how many rows you want to discard. You click on Update Preview, and it's already done. So once you're happy with the way it looks, you click on Create Project, and you have this. You have your data in front of you. Now you might notice a couple of things that you might want to edit out. For example, those square brackets here denote links to references in the wiki page, but we have no use for them here. So one thing that you can do is you click on the column header, and then you click Edit Cells Transform, and you have this nice window that allows you, by using the Grail language developed for Google Refine, to edit your data. I should mention that Ontotext has been developed on top of OpenRefine, which was previously known as Google Refine, but it has also added quite a lot of nice features, such as the virtual Sparkle endpoint, which we'll cover in a couple of minutes. But first, let's remove those pesky references that we had before. So here I'll use a regular expression in the Grail language. If you're not familiar with it, there's a nice documentation on GitHub. So just Google Grail, and you'll be immediately directed there. So here we'll replace those square brackets with an empty string. And here the dot identifies any symbol, and the star identifies any length of such symbols. So we close with the closing bracket, and we replace this with an empty string. So if we scroll down here, we see that, we see here that we successfully managed to edit it out. So we click on OK. That's all done. Next, rather than having this data as strings, or instead of having it as strings, we might want to convert it to integers, so we can later on compare them using some math functions. To do that, again, you go to Edit Cells, Common Transforms, and you click to Number. However, once we do that, you see nothing changes. And the reason for that is that we have those commas in the data, so we can quickly edit that out as well. So as before, we specify we want to remove the commas. And once that's done, you can see now that we can easily convert the data to numbers. Here we might also want to remove all those references and clean up our data as well. So let me quickly do that for you. So we got rid of the references, and I'll also do another quick function to just get rid of the empty spaces, which will make some of our later operations a bit easier. And the last thing I want to do about this data is it already looks kind of nice to me, is I would want to remove the information about the European Union, as it's technically not a country. So a nice feature here is that you can select your roles. You can start them, or you can also flag them. I will start them, and then you can do faceting. Here we do faceting by star, and we select that we want to only isolate the values which are true. And once we've done that, we can easily remove all the matching rows that match to that particular facet. Once we've done that, we remove all the facets, and we're back to our data. Another neat feature of OntoRefine is that in case you make some mistake and you want to go back, it keeps full history of all your commands. And you can always go back to a previous version or go forward a few steps. Another great thing is that if you have similar data that you might want to edit in the future, you can also extract the commands. So you can copy them, and later on when you open the new data, you just click on apply, and you paste the set of commands that you've prepared from before. You click on perform operations, and it's all done for you. Now we have all this data looking already quite nice. So let me get back to the other data set that we had, which is the list of largest companies. Here there are quite a few more columns that we have, so in the interest of time, I've cleaned this earlier, so we don't have to spend 2 hours just cleaning the data in front of you. So I've prepared it already in RDF format, and if you want to import RDF format, you can click here on import RDF, you click on the file that you want to import, and we have this in the turtle format. You click on import, and you enter all your data here. But one important thing I forgot to mention is that before you import your data, you should first create a repository. So how you create a repository, you can go to Setup, Repositories, click on a repository, and you edit your repository ID, repository title. You click on the rule set that you want to use our first, and you also specify the base URL. The other settings you can pretty much leave as their default values for most small purposes. So we click on create. We then want to connect to the particular repository where we'll load our data, and once we are connected, you can also see it here. This drop-down menu here allows you to also quickly switch between the different repositories that you have. So once you've done that, again, we go back to import RDF, and we would want to import the file. So we select it, we click import. Here we specify the base URI and the context. The context is also known as name graph. Some of you might know it with that name. It allows you, briefly, it allows you to keep the data coming from different sources separated while you keep it in the same repository. The nice feature about that is that you can later on either export them or modify the separate context without needing to touch the other contexts or name graphs. So here you see you can select multiple RDF formats in which you can export a particular repository or a particular name graph. And you can also, as I mentioned, remove the particular graph or clear the whole repository. So we've added the data for the companies where we had the name of the company, the industry, the revenue, and so on. We want to get back to our data about the country's GDPs. So this was the file that we added here. Once you open it, you can see the virtual Sparkle endpoint here. And if you run this basic query that returns all the triples of subject, predicate, and object, you would see that the virtual repository is already populated. However, you might notice that the default properties and resources are not as you might want to format them. So a nice thing you might want to do is use spin functions to convert them. For those of you who are not familiar, I would encourage you to check out spinrdf.com, where you can read a lot about this nice semantic technology. So if we want to import our data from here into our repository that we've created, the first thing we should do is copy the Sparkle endpoint. So we copy the endpoint and we write a Sparkle query in our repository. Here I've predefined the query, and we'll only change the endpoint to which we are connected to. So we use the service or a federation query in order to access the data which is available through the specific Sparkle endpoint. And what we are doing in this query, for those of you who are not familiar with Sparkle, is we select particular patterns in the data, and we extract them, and later on we insert them in a named graph, or again context specified here, into our current repository. So once we click run, okay, excuse me for a second. Let me check if I copied the Sparkle endpoint correctly. I apologize for this. It will only take me another minute to resolve the problem. I'll run you through what I'm doing. So we'll create a new repository quickly, and again we specify the base URL that we want to use. We click on create. We connect to the specified repository, and now we want to import our other data that we had. So largest companies, click on import. Okay, so we've successfully imported that one. Now, okay. So now we've added the 150 statements from our other data that we had. Again, that's the countries and their respective nominal GDPs. And if we go into this section of context, as I mentioned earlier, we imported it into a particular named graph that we specified. So now you see that there are two separate graphs here. And this will become important in a couple of minutes. But let me come back to the example queries that we've prepared for you. So the first one is we'll check the revenues of the particular companies, and we'll group those revenues based on the similar countries that they have. So that's done. So if we output this table here, you see for every company and we see the respective revenue and country. And in order to get some idea of how they stack together, we can use a stacked bar chart where we just sum over the revenue, and we want to sum over the companies for specific countries. So here you see that the companies coming from the US amount for the majority of the revenue, followed by the People's Republic of China, and next is Germany, and then Japan is a close fourth. Now, another way you might want to do that is rather than summing those revenues in the graph, you might want to do that before that in your query. And for that, you can just use the group by operator here. So we group by the country, and if we run this query here, we get the output is now the countries and the respective summed revenue. So if we decide, we might want to also use Google chart to plot this data. So you have here a wide selection of possibilities of how you might want to plot your data. I'll just use a standard pie chart for this. So once we plot it, you see the US again amounts, the companies from the US amount for about 42% of the revenue, followed by China, Germany, and Japan. Now, we might be interested into how this compares to the GDPs of the respective countries, whether there's some similarity. And for that, we'll run a query on the country's GDPs. Here I've prepared one, and you might note this new addition here and this is the URL to the specific name graph, which corresponds to the data with the country's GDP. So if we run that and we stay in the Google chart, it immediately is plotted. And again, the leader is the US, followed again by China. But here you see Japan has come third, and Germany is now fourth. Apart from all these nice visualization options that you have with GraphDB, another thing you might want to do is you might want to inference new data from the data you already have available. So for that, you want to leverage the capabilities of schemas and ontologies. The first example for that is using the RDF schema property range, which specifies what is the class for the objects of a particular property. In this case, we picked the property has country, which was a property of the specific companies denoting their respective countries. So here we selected the objects are of class country. So if we run that single fact that we've inserted here, you see we've added only one statement. However, if we decide to describe the US as a country, you see here that we not only have the data for okay, let me get back to the next example, and I'll try to return to this in a little while. The next example is using the OWL same as function in order to specify that resources from the two separate resources are in fact the same. So here we have the US from one of our data. We want to specify that it's the same as the United States in our other data, which comes from the country's GDP. And another thing that we've included, the second fact, is that the US is also the same as the Depleted entry for the United States. So if we run that query, and we decide we want to describe the US, here you see now that this information is already added. So we see that the Wikipedia resource United States is the same as the US, and also previously we entered that the class of the US should be the class, sorry, of all objects for the property has countries should be countries. So here we see that this information is also available for this particular property. Sorry, this particular resource. If we now, the next example that I've prepared for you is showing the capabilities of, again, of the web ontology language, OWL. And here we're demonstrating the inverse of function that defines a property as being the inverse of another property. So here we might want to access the data linking particular companies to their countries, not only in one direction, saying that a particular company has a particular country, but we also want to go the other way around. So if we insert that data and we again go to describe the US, you can now see that the US, there's a lot of new data specifying that the US is the country of, for example, AT&T or Apple or Chevron and so on. This is particularly useful when you're not familiar with the data that you're using, and you might not know the person who generated this data, whether they decide to go in one direction or the other when defining the relationship between different resources. But if that person has already included the information about the inverse property, you wouldn't have to worry about such problems. Now, another thing some of you might have noticed is that in one of our data sets, what we had was the GDP expressed in millions, and in the other one, we had the revenue expressed in billions. You might want to standardize your metrics so you can easily create new triples based on the existing information that you have in your database. So here we insert new triples corresponding to the revenue of companies in millions rather than billions, and we do that by using the information about their revenue expressed in billions, multiplying it, of course, by 1,000. So if we run that, you see that 46 new statements, I guess that corresponds to the 46 companies have been added. And if we decide we want to see how the data for a particular company looks, we just click on describe. We use the describe query, and here we selected the company Apple. So here you can see the revenue expressed in billions, what we had before, and the new addition expressed in millions, as well as all the other examples that we've already shown you, such as what is the country, and another thing that you might notice is that although we never explicitly specified that the Depleted entry for the United States is the country of Apple, since we've already have the links between the Depleted entry and our local entry for the United States, it already infers that this fact should be true as well. And if we don't want to see the inferred facts, but only the explicit facts that we've included in our data, we can just exclude the inferred data in our results. And if we run that, you see that there are only 10 triples or 10 different facts, you might want to say, that we know about the particular company. But again, including the inferred, you see now we have 15. So it's a nice feature of ontologies that, although I didn't have to write these 5 particular new facts, they're automatically generated. Now, another thing I want to bring your attention to, because you have all this inference, you want to be careful in how you use it. So if I just run a query asking for the countries and revenues of specific companies, and if I'm not careful, you might see that now, for example, we have all this data for the Depleted entry of the US, our local entry from our other name graph for the US, and if we plot this table as we had before, so we plot it as again stacked bar chart, we sum over the revenue, and what you might see here, you see these duplicates in data, and this is not a very nice thing to see, but you can easily get rid of that problem by making sure that you only specify that you're referring to the data coming from a particular context. In this case, the context is the company's one. So if we run it again and we generate our bar graph again, you can see that those duplicate entries have been removed. Now, all of these are just a few toy examples of how you can use GraphDB and how you can use ontologies linked to open data. But let me also show you a few bigger projects that Ontotext is being involved with, and you might get a bigger perspective of what advantages you might have in using semantic technologies. The first one I'll cover is the BBC, and we always start with this particular example as the BBC Dynamic Semantic publishing platform that Ontotext developed was the first really mass adoption example of semantic technologies. It was developed for the 2010 Soccer World Cup that happened in South Africa, and what was really a big challenge at the time was that during the World Cup there were over 10 million hits per day on the databases, and using other technologies that probably would not have been feasible at the time. However, our GraphDB handled that perfectly. Soon after BBC adopted this for the World Cup, they also expanded it and used it more generally in their BBC Sports section, in their music section, and many other areas of their business. But what in particular we did, one of the notable features was that the dynamic semantic publishing platform assembles web pages on the fly. So how it does this is by integrating the data from multiple sources, not only databases that come from specific internal departments, but also it was leveraging a lot of external data that came from linked open resources. So using all of this additional information, they could really bring more content, BBC could bring more content to their users. Before using the DSP, or the Dynamic Semantic Publishing Platform, the editors in BBC had to do all of this manually, which was both costly and time-consuming. But not only that, but it apart from saving costs for BBC, it also enriched a lot the user experience, because the other notable feature was that it automatically, the DSP automatically enriches the news articles by adding a lot of additional information about the resources that are either in the article or also relevant to the particular article. And an example of that would be, for example, this page about the Chelsea soccer team. What was automatically generated was also information about the last game, the upcoming match, as well as the current standings in the Premiership, latest videos, but also not information that was directly about the Chelsea football team as a whole, but also particular players or the coach. So here we see that the main news story about the team is actually focused specifically on the team captain. Similarly, as I mentioned, the DSP was expanded and went into the whole sports section and also covered the following Olympic Games. Another use case that I want to describe to you is the Financial Times. The Financial Times wanted to develop a horizontal platform that is both for data and for content. This platform is currently in production. However, some of the functionality is already implemented and can be seen. You can see it in the recommended articles, for example, which apart from other things also uses the user's recent searches in order to figure out what other news might be relevant to that particular person, and it also takes into account when those searches are made. So the more recent searches are given higher importance, as every person's interests might change over time. So it takes into account that, and it doesn't only recommend you things you were looking for, let's say, a month earlier, but it focuses more on what you're interested in right now. Another use case was the LMI, and what LMI needed was they had a lot of legal documents that they needed some way to automatically analyze, and those legal documents contained some very specific data. For example, it contains some documents might contain information about importing restricted goods from one country into another, and the main goal was to be able to identify which are the key components, what are the things that the people using these tools need to focus on. Following that, an example from the life sciences domain, we worked with AstraZeneca to allow them to improve their testing of new drugs and discovering treatments and applications for specific drugs. So the problem that is very common in this field is that there are already a lot of clinical trials made, and performing new clinical trials is quite expensive. So it makes a lot of sense to return back to the clinical trials that you've already had and try to figure out whether you can extract more information from them. And it's not only internal clinical trials, but the governments require all companies to also make the information about their trials freely available. So any company is also capable of using the information from the other companies. So what we did was we took a lot of open resources, and we loaded them all into using our GraphDB. And once we've accumulated all of this knowledge, we could use it to find new applications or side effects or interactions with other drugs. We do that by first taking the raw documents, the algorithms analyze the structure and understand the context of the documents. Later, the information is annotated to extract the relevant knowledge and to remove any ambiguations that you might have in the data. And finally, it enables people to perform semantic search on the data, which is also indexed. The final example that I want to show you is for Euro money, and again, the problem that they had was the mass quality of documents that they had stored in different archives, and what they needed was to find a way in which all the investors that are using the Euromoney reports can be able to find the information that they're interested in more easily, rather than having to manually go through each individual document and try to figure out where the relevant information is hidden. As you might see here, we've also included a graph, because a key problem that was specific to Euromoney at the time was that they also had a lot of information hidden in graphs and tables, and we also had to find a way in which we can extract this particular information as well and make it searchable. Now, with this example, I'll conclude, and I'll just direct you to our support and fact section. You can contact us with any queries at support@ontotext.com, and you can also check our additional resources, such as our community forum at Stack Overflow. You can check the GraphDB documentation, as well as our Knowledge Hub section at Ontotext, where you'll find a lot of nice white papers, as well as some interesting posts describing the fundamental elements of semantic technologies. And also, you can, of course, access the freely available resources on RDF, Sparkle, OWL, and all other semantic technologies that are managed by the W3C community. And with that, I would like to thank you, and also I would like to remind you once again to fill out our survey if you haven't done so, so we can keep bringing to you new webinars with time.
Thank you, Peter, for this informative and exciting live demo of GraphDB 8. Dear all, for information, a beta version of GraphDB 8 will be available for download very soon. This webinar is being recorded and will be available in a few days. And now Peter will answer your questions, and if some of them are not answered today, we'll contact you with a response by email.
So the first question is, if one data source uses OWL2 and another one just uses plain RDF, how do you integrate those two? Well, you can create a repository that where the rule set account for OWL2 it's more broader than RDF, and this one will also take care of all your data that is just plain RDF. So the next question is, I'm guessing that Ontorefine is based on OpenRefine. Therefore, can you tell us what is the difference? Well, there are a lot of small differences, but the main thing that I want to point out is that unlike the main thing is that you have this virtual Sparkle endpoint or the virtual repository that allows you to play with your data without having to import it into one of the other repositories that you have, and you can figure out whether the data that you're cleaning up here already looks the way you want, and afterwards you can connect to it through a federation query and extract your data as we demonstrated before. Can you make this functionality work with other sorry, I lost the question. With other expression languages, I'm guessing that this question refers to the regular expression that I was using to edit the cells. And here you see there is a drop-down menu where, apart from the Grail language, you can also use Clojure. But in my personal experience, Grail has more or less been sufficient so far. What is the difference between the Sparkle tab on the left and the Sparkle from the button in Ontorefine? So the Sparkle here on the left refers to, it brings you to, it allows you to query the repository to which you're currently connected, while again the Sparkle button here allows you to query the virtual, the data in the virtual repository that you have in Ontorefine. Does GraphDB support spatial queries? GeoSparkle, yes, it does. What makes OWL superior to RDF? Well, RDF is the resource description framework, which specifies how the data is expressed in terms of triples. So you have the subject, the predicate, and object. Perhaps your question is what makes OWL superior to RDFS? RDFS is the RDF schema, and it allows you to define such things as class hierarchies or property hierarchies, saying that a particular property is a subproperty of another one. It also allows you, as we mentioned, to define the range of a particular property and also the domain. The difference between the two is that the range corresponds to the property's object and the domain corresponds to the property's subject. While OWL is, the web ontology language has a much broader set of rules that you can use for inferences, and depending on the sub-language that you use, you can use a subset of those rules. What are the main differences between GraphDB and OpenRefine? Well, I guess it's Ontorefine and OpenRefine, and we kind of answered this earlier. Does GraphDB process unstructured data? Yes, you can express this unstructured data in terms of triples, and the new addition in this case is that you can use tabular or structured data, while before you were also able to use unstructured data. So this feature is still available. What about the entailment regimes in GraphDB? Let me give you an insight. So we have a bunch of rule sets, and we are adding more. You asked particularly about the AODL profile. We don't support the AODL because it has no guarantees for whether your problem is computable or solvable, and for that reason, while it has theoretical uses, it's rarely useful in practice. So we use a lot of other subsets of AO that are more or less sufficient for any practical cases. Where can I find simple examples about textual data processing, information extraction, and semantic search capability? I will first encourage you to have a look at our Knowledge Hub. Let me bring that again. So the link to our Knowledge Hub is ontotext.com/knowledge hub, and there you can start with the fundamentals, and if you require any additional examples, feel free to contact us, and we'll be able to help you in more detail. So let us stop with that, and we'll answer all additional questions in our follow-up email.
Okay, thank you all for your time and for attending this event. Thank you once again, Peter, and we'll see you soon. Bye.